so today I wanted to take a little bit different approach to the video. Wanted to dive in and really look at the refrigerant flow and what the refrigerant's doing within one of these Mitsubishi VRF systems. And so I took a minute, printed off the schematic. These are a little different than the ones I started out with. These are from the N gens. And so you can see here it's a PRY. It's all the way from an EP72, which is a 6-ton, up to an EP144, which is a 12-ton. It's a T and a Y and a NU-A. So it's a 6 to a 12-ton high efficiency air source VRF outdoor unit. And so this is the schematic for a single condenser. And so if you had them twinned for like a 24-ton system or whatnot, you'd have two of these. All right. So anyways, as far as color coding goes, red here is going to be your hot gas. Blue, superheated suction gas. Dark blue is suction liquid or saturated suction liquid. Purple is oil, which is in a couple places. Orange is going to be high pressure liquid or subcooled liquid, depending on how it is. Any components, LEVs, valves, whatnot, I've put in brown. And yeah, that's pretty much all the colors that I'm using there. And so I'm going to go through and just identify some of the main components that you've got here. And I've actually got, this is showing the condenser in cooling mode. And I've got another one that I did for heating mode, which we'll go over in a little bit. So we'll start with the compressor here. So obviously suction line in, discharge line out. We've got our sensor at the bottom and the oil. And then this is actually, maybe, but I doubt that it's used in cooling mode. But this line here is actually a third pipe coming in for flash injection. So yeah, discharge line comes off, gets caught on the oil separator. You know, we catch and recover any oil, we come back, and we have a cap tube, that's CP1, it's cap tube number 1, as well as a solenoid we can open, and it dumps back into the suction line here, right by the compressor. And it's kind of tilted to drain back to the accumulator if, you know, the compressor's not running. But with the cap tube there, it just kind of bleeds on a regular basis. From the oil separator, we come up. This is one of the ports that we have. This is the one I believe that's usually in your bottom right panel. And then you also have your high pressure switch and your 6.3 HS1, which is your high side transducer. Come over here, it tees off, and it goes to our two reversing valves here. And then from here, we also have a couple little lines that snake off, like this guy here. This little line actually comes off and hits the bottom, I guess the bottom circuit on these two coils. And what this is it's a constant, it's a dedicated condensing loop. And if you look, the liquid comes back through a strainer to LEV9. And LEV9 is dedicated to cooling the inverter. On the N gens, Mitsubishi went to a refrigerant cooled heatsink versus an air heatsink like they had in previous generations. And then yeah, it comes through, cools, and that dumps back over here in the suction. So off the compressor, through the oil separator to our reversing valves. And in this mode, it's going to be passing that hot gas back to this coil as well as this coil. And yeah, so it's going to go through, obviously, de-superheated, change of state, subcooling. Typically only lightly subcooled. Most of the subcooling, like you'll see later, is going to be happening down in the branch controller. Okay, and then we have these two valves. I imagine they'd be full open in cooling mode just to allow the gas out, or to allow the liquid out, I should say. They come back together, come back, that's where you're feeding LEV4 if you were running it. Yeah, and then this is also not used in this mode, this liquid gas liquid separator. We'll talk more about that. It's mainly for cooling mode, I believe. And I'm not exactly sure what they've got this LEV2D doing. It bypasses the condensers. I suppose I could use it to build head pressure during low ambient cooling. But as far as I can tell, it's probably not used. So liquid comes off, and then we have, this is new for the engines, we have this check valve block, which is basically, I think it's a solid assembly with a set of 3 check valves and an orifice built into them. And in this cooling mode, liquid's going to come in, check through, and then come down to our high pressure side. And so we have 2 outlets on the condenser that are going into the space. One is our high pressure side, one is our low pressure side. And the direction of flow on those is consistent. Like the suction is always the suction, it's always coming in. And the high side, or that's the low side, the high side is always high and it's always going out, whether it is hot gas or liquid. And then, so for the low side, it comes in, hits this reversing valve, comes back, picks up that line off the cooler, the inverter cooling circuit, and then comes back to the accumulator. So pretty straightforward. Here's the same condenser, but it's in heating mode. And so the direction of flow and a couple things flip around. So obviously we still have our compressor here, accumulator, everything's roughly in the same place, oil separator, it's all the same. We come up and we're going to be feeding hot gas to our 2 reversing valves. This one in this mode dead ends here, and we have the hot gas being passed, and it's more or less going to just pass straight out of the unit. We do have that dedicated cooling circuit that's going to, be feeding that. But other than that, that's about all we have on the high side. So we have hot gas leaving the outdoor unit to go inside. On the low side, it gets a little bit more interesting. It loses this path. So this check valve closes, and it's going to go through this method, or this path. And then it's going to backfeed here to the liquid gas separator. So liquid gas separator is interesting because if we have a mixture of liquid and suction gas, the liquid can be pulled off the bottom and fed to the coils, and the vapor can be bypass the coils. This valve can be opened and fed right back in, and so it's not wasting capacity trying to boil off refrigerant that's already been boiled off. We also have pure liquid being fed to LEV4 here, and so we have the flash injection going on. And so as the compression ratios run high, as the I don't know that they've ever given exact logic, but as it's required, this LEV can step open, step closed, and feed that saturated liquid straight into the compressor, straight into the scroll, to help build head pressure and help cool the compressor off. So we have our liquid that comes in, splits. We have these 2 metering devices, LEV 2B and LEV 2A. They're kind of the throttling valves. They're not actually metering. The metering is happening elsewhere. But they're throttling valves to just kind of keep the flow through these coils. And yeah, so they come through, fans ramp up, we boil it all off, they come and they feed back. And so in this mode, the reversing valve would be flipped. It's going to feed these 2 circuits back to each other. And then yeah, they're going to come down to the accumulator here and back to the compressor. So in this mode, in heating mode, what we're going to have is the suction still going to be coming into the unit, but it's not going to be superheated. It's just going to be saturated suction liquid. And then we have discharge gas going out from the condenser. Okay, so that's a rundown of what's going on in the outdoor units. Not going to touch on defrost, that's kind of its own subject, but obviously things rearrange and change what they're doing in that kind of a situation. Okay, so let's go back. This is a branch controller, and I've actually got, this is a main. You see here, this is a CMB 1016 NU-KA1, which is considered a main branch controller. And this one is a sub-branch controller. It only shows them with 6 ports, and it shows a sub with 6 ports, or with 4. Obviously, this is more ports. It would just continue, it would just elongate. And you can have up to 16 of these. It's just showing more or less what the arrangement looks like. So this is for cooling only mode. Or sorry, that's the wrong one. Let me get the appropriate one. Alright, this one is for cooling only mode. And I haven't been perfect at this. I'm trying to highlight the main sections that would be in play. So some of the piping isn't colored. So in cooling mode, we're again sending that liquid in on the high side, on the high pressure side. The first thing that the high side comes to is this gas liquid separator. And this, in some modes, doesn't really play much of a role. In others, it plays an important role. But for the purpose, basically, liquid is going to go this way, and the hot gas will come off this way. And so in this mode, cooling only, it's all liquid. There's not really anything coming off the top. So the liquid comes in, and we come to our first subcooler here. There's 2 of them, one here and one here. And so everything hits this subcooler right away. And we have, it's kind of tricky to explain how these work. So this assembly here is kind of opening and closing to maintain flow through this section when we want it, and closing down when we want the gas to go this way. Because if hot gas is coming in, we don't want it to go through, you know, to our liquid header. We want the gas to go to our hot gas header. We'll get more into that in the other breakdowns, the other modes. But for cooling only, these are more or less open. And these 2 guys here, PS1 and PS3, they're pressure transducers. And so it's going to be reporting a pressure here and here. And it drives the logic on these, how open or closed they need to be. But the liquid's going to come in, pass through all these open valves, come up to our second subcooler. And then it's going to come here, and it's going to be in this liquid header. We have 2 liquid headers, and I'll get more into that in the heating mode. One of them is feeding units that are in cooling, and one of them is accepting liquid from units that are in heating mode. And that's this header here. It's not colored. It will be in the other modes. But as liquid comes back from the units that are in heating, it comes into this header, and then it tees back in right here, and it has to go through this subcooler before it can go out to units that are in cooling mode. So cooling mode, we come in, we split off through the first subcooler, through these that are open, through the second subcooler, and by the time we're here, we should have at least 20-30 degrees of subcooling. This component here, this check valve block, both liquid headers are served by nothing more than check valve assembly. And so basically you have 2 check valves, and it's for each port, it's either it's open or one of the 2 is going to be open and the other one will be closed. So in this mode, we're going to be checking out of the cooling header, the liquid cooling header, or whatever you want to call it, and the one that connects to the other header will be closed. So I've got 4 ports here. They're all in cooling mode. They're going to go out to the units. There's a metering device in the indoor units. It's going to be, throttling open and closed, maintain superheat, and then we're coming back on this side. So this is our liquid line. That would be the smaller lines coming off the branch controller. And this over here, it's going to be your gas side, and it's going to be the larger lines off the branch controller. So our liquid checks out, it's metered at the unit, comes back as superheated suction gas, and we have this assembly right here. And it's kind of hard to see real well. Let me see if I can zoom in on it real quick. Yeah. But what it is you have 3 solenoids and an orifice. The orifice is obviously just constant, and when that branch is not active, liquid or gas or refrigerant that's, you know, in that line will slowly bleed back to the suction line. But there's two here. One's a small size port and one's a large size port, and those both connect the gas line to the suction header. And then there's another one, which would be solenoid B. Solenoid A and C connect the gas line to the suction header. Solenoid B connects it to the discharge header, which is not colored here. It's right here. It'll be colored in some of the other modes. But for cooling mode, solenoid A and C, which are these two, are going to open and connect the gas line into the suction line. So we have suction gas flowing back here, getting carried back up here again. Yeah, okay. One other interesting component here is off of this port, we have LEV3. LEV3 serves a couple purposes. One, it's going to be taking liquid off that header and metering it through and feeding, you know, suction saturated liquid through the two subcoolers, and it tees back into the suction. And how does it know how much to feed? Well, it's got a sensor here and a sensor here. It's comparing the two to get an idea of superheat. So I mean, if this is 44 degrees and this is, you know, 48 degrees, it knows it has 4 degrees of superheat, for example, which ironically I believe is the target in most of the modes, or in the cooling modes at least. So we're feeding through here on the subcooler to get that subcooling on the liquid going out. In heating mode, talk about this a little bit more. In heating mode, this is the primary metering device for the branch controller. We also have LEV4 here, which connects from that liquid header over to the suction. And this, from what I understand, is primarily used in defrost. I'm not going to talk about it a ton. It's new. The N-Gen branch controllers had this valve added. The older ones did not have it. So not entirely clear on its purpose, but from what I understand, it's used for defrost. Okay, so let's look at the branch controller in heating mode. Actually, before I move on from this one, it's the main. Off of the back of the main, each of these headers obviously connects out to the lines, you know, go into the indoor units. On a main branch controller, there are 3 lines that come off the back. One is liquid, that's passed through one subcooler. One is gas, or hot gas, and one is suction. And for whatever reason, these labels are incorrect. Mitsubishi, if you're watching this, you might want to go fix that. But we have these 3 lines that extend and are used to pipe out to sub or branch slaves or BS boxes. So this is what a BS looks like. And so basically, you know, we have our suction line here. Discharge line, the header would be here. It's not colored in this mode. This is for cooling, obviously. Liquid comes in. We have a single pressure transducer, which I guess you could compare to this to get an idea of what the, you know, pressure drop might be. We have a single subcooler, because again, the liquid coming out to the BS box has already passed through one. It's picked up about half the subcooling it needs, and so it's going to come in and receive that second batch of subcooling before going out to the units that are in cooling mode. Those go out, come back, superheated suction gas, which it feeds back into that suction line, feeds back in here and continues back. And it also has an LEV3, bleed off any excess liquid, and also to maintain the subcooling here. It has those 2 temperature sensors. Okay, so that's the branch box in cooling mode. In heating mode, it's kind of similar orientation, pretty basic. Gas liquid separator isn't doing a whole lot. I mean, obviously we're going to have hot gas here. We might get some condensation. These more or less are going to be not totally closed, but pretty closed off. We don't want the hot gas to go this way. And so there's an intentional pressure drop that's created across these. These solenoids will likely shut, and LEV1 will open and close, maintain that, which is calculated between these two pressure transducers. Hot gas is forced down this way to the hot gas header. And then also we have this line that comes off and goes to that hot gas line going to the BS box. So again, we have the 3 solenoids here. The 2 connecting it to the suction would be closed, and we open solenoid valve B for those ports that are in heating mode. It's going to connect hot gas. Hot gas will flow out to the indoor unit. Obviously, it's going to ramp the fan up, pick up some subcooling, come back as liquid. It's going to check into this medium header here, and again, it's going to feed back in where it goes through, picks up the subcooling that it needs, and then it can come in and feed LEV3. All of the liquid, in heating only, all of the liquid refrigerant is being metered by LEV3. And so it stops caring so much about maintaining superheat here, you know, through the subcooler. At this point, it's just opening and dumping the liquid. We need to get this liquid through. We need to get it out to the outdoor unit so we can pick up heat. But it's going to, you know, go through the 2 subcoolers, T in, and then it's back out to the outdoor unit. And so again, heating, cooling mode, suction line always is going to the outdoor unit. High pressure line, whether liquid or discharge gas, is always coming out. This is useful because it makes cleaning up the system relatively easy. Check valves don't become a huge problem. You can put a filter dryer on it without, you know, some crazy piping arrangement, which I'm wearing. That's not the case with everybody. So the branch controller starts getting a little interesting in some of the mixed modes. And so here we have simultaneous heating and cooling going on. And this mode, what we're looking at is, so out of the 4 ports we've got 3, and let's just pretend, I don't know, we got a 12-ton unit and we got 4 3-ton indoor units. So 3 of them want cooling, 1 wants heat. So this would most likely put the system into cooling main, which is mostly cooling with a little heating. So in this mode, the outdoor unit is not going to subcool the refrigerant. It's going to bring it to a saturated state, relatively high pressure. So the condensing temp might be 115, 120, and it's going to bring it in with basically 0 subcooling. So in the gas liquid separator, the liquid's going to come off the bottom, and the hot gas is going to come off the top, and it actually separates. And this is the main purpose of this chamber, is to accomplish this in this one mode. Liquid's going to come through, obviously picks up subcooling. These are going to be maintaining that pressure differential, not so much to restrict the flow, but just, you know, so everything doesn't come this way. But we come through, subcooling here, passes through, subcooling here, and now we have subcooled liquid to go out to our units that are in cooling mode. For that one straggler that wants heat, Barbara in the corner, you know, her room can't be warm enough, we're going to have the hot gas come off the top, and it's going to flow this way to the discharge header for this one unit. And so obviously this one, solenoid A and C are going to close, solenoid B is going to open, and we're going to flow hot gas out. For that one line, liquid's going to come back, check into that intermediate header, and then same thing, go through the subcooler, come back out, and then it can flow into the units that need cooling after it's gone through and picked up the remaining subcooling that it needs. The 3 units that are in cooling, we're bringing superheated suction gas back, and then LEV3, you know, is in this mode would mainly just be maintaining superheat and trying to hit the subcooling that it needs. So we're feeding that back. So that would be in a cooling dominated mode. No, right. For the sub, the liquid that's passed through one subcooler is going to come off. That's going to be coming down here. It's going to go through that last subcooler. And if you look, so we still feed the heavily subcooled liquid to the 3 units that are in cooling. And those are going to come, bring back their suction gas. We do have hot gas that comes off the header here, right here, this line. So that's going to feed to this discharge gas header, feed into that 1 unit. It's going to come back, check in, back, through, subcooled. Yeah, and then it can either flow into the units that need cooling or through LEV3 and feeds back. Last mode is more or less, it's also a simultaneous mode, but instead of majority cooling, it's a majority heating. And so it's very similar to regular heating mode, except we have a couple ports that are needing cooling. In this case, it's 1, but we bring the hot gas in. Again, this is really restricted down. We don't want the hot gas going this way. We might get some liquid from the subcooler. Hot gas is going to be forced to the header, flow out to those units that need heating, come back as liquid, and it's going to flow back, pick up subcooling, go back out to that 1 unit that needs cooling, come back, get connected to the suction, and flows back. This section might be superheated. From here, we're going to be dumping, LEV3, again, is going to be dumping the remaining liquid that's not being used as saturated suction liquid. And so we're going to be in that mixed state. And that's where that gas liquid separator outside would be helpful. But yeah, and it's going to float between these modes seamlessly, just depending on what the load is and what is calling. Same sort of a thing. Basically, that's what you're looking at in the sub. So that's pretty much all I've got for you. If you got questions or there's things I missed, or if I totally missed the mark on something, feel free to leave a comment below. Hopefully this little illustration, although repetitive, may have helped you and clarify kind of what's going on inside the branch controller. Share this with somebody that is working on these, that's trying to learn and understand. Subscribe to the channel if this is the kind of content you'd like to see more of. So until next time, guys, my name is John, and this is VRF Viewpoint.